Hello and welcome to my three-part series on water vapor equilibrium, where I will be discussing the concepts, obtaining some data, and using Antoine's equation to graph said data in a Python plot. In this video, I will be discussing the concept of water vapor equilibrium along with some examples of where you may find this in your own home. This is the phase diagram for water. It is the relationship of pressure in atmospheres and temperature in Celsius of pure water. Emphasis on pure. This diagram is only accurate if nothing exists in the space being observed besides pure water, no air. In the bottom section, water exists as a gas, in the top right as a liquid, and in the top left as a solid. We can see these three phases separated by these red lines. As you can see, there are a few important things labeled here. We can see the normal freezing point and boiling points at 1 atmosphere, at 0 degrees Celsius and 100 degrees Celsius respectively. We can see the triple point, where all lines separating the phases of water come to one point. Therefore, at this point, all phases coexist. But what I especially want to point out is more visible on the next slide. On the left, we see the same diagram in simpler terms, where I've highlighted in red the line separating the gas and liquid phases of water. This is where water vapor equilibrium can occur, and it's also representative of the trajectory the system follows as it is heated. As we can see, this is the line that separates the liquid and vapor phases, and as pressure increases, temperature increases. When water molecules are moving from liquid to vapor phase and from the vapor to the liquid phase at the same rate, they are in equilibrium. This is somewhat easier to see in this middle diagram, where the little red dots represent water molecules. Down here in the liquid phase below the horizontal line, we can see all of the little red dots in the liquid phase more condensed. And above the horizontal line, we can see all of the molecules in the gas phase. And these arrows of the molecules crossing this line is representative and labeled as a phase transition. And in equilibrium, these molecules will be moving across this line at the same rate. And an even simpler way to view it is this picture of a boiling pot of water, where water molecules that are liquid molecules are represented as blue, and the vapor molecules are represented as white. And they're these little smiley drops that are going in and out at the same rate. The first and probably most accurate example of this in your home would be a pressure cooker, where eventually all air is removed and only water and water vapor remain. The internal pressure rises when heat is applied because the temperature rises and the water molecules cannot escape. Using a pressure cooker is a great way to cook meat because the food retains its moisture and cooks quickly. A more familiar example is a simple boiling pot of water, but would really only be accurate if we boiled the water until all air was expelled and then somehow perfectly sealed the pot with the lid without any air trapped inside. If we were able to do this, the liquid water would be turning into water vapor, and the water vapor would be turning into liquid water at the same rate at the right temperature.